So what is this? A box plot is a representation, or is a way to show these, the maximum, the minimum, and also the quartiles. Okay, so it's a super fast way to see what is the distribution of the data set. So this is a box plot. We have the minimum, the maximum, Q1, Q2, Q3, and please remember, Q2 is always the median. Q2, let me write down this. Q2 is always the median, okay? And also, if we want to find the range, remember that we have two. One is the range, and then the second one, the inner quartile range. So when we want to find the range, it's super easy because we need to find the maximum or the biggest number minus the minimum, okay, the smallest number, and that's it. When we are talking about the IQR, inner quartile range, we have something different, because in this case we need to do a subtraction. The upper quartile, the Q3, minus the lower quartile, Q1. Okay, so this is just a reminder. Then, how can we build this box plot? So first, this is an example. We have a fitness trainer is analyzing the number of push-ups completed by a group of 18. Okay, in this case, this is not 18, this is 12. Okay, so 12 participants. During a workout session, the trainer recorded the following data set. Okay, so we need to display this, we need to show this using a box plot. Then determine the outliers, and then what else? Describe the skewness. Okay, so first we need to go to our calculator to find Q1, Q2, Q3, the minimum and maximum. Okay, we need to go to statistics. Go to statistics. Then, using the list number 1, we are going to add all our values: 10, 18, 20, 22. So we can start with 10, we press execute, 18, execute, 20, execute, 41. Okay, once that we have our values using the list number 1, we need to press calc. So we can press F2 to choose calc. Here we have these options: 1 variable, 2 variables, regression. So we are going to choose 1 variable. So press F1 here. So here we have results. So what is the meaning? For example, X, this one with the bar here, this means the mean or average, N is the number of items or the number of values. As you can see, we have 12 because we have 12 participants. So what are my Q1, Q2, Q3? What are they? So we need to use the directional path. I'm pressing down, 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 and here we have the mean, the Q1, Q2 is always the median, Q3, and the maximum. And that's it. So we need to copy these values because we need them to build the box plot. Once that we have used our calculator to find these values, Q1, Q2, Q3, maximum and minimum, remember the goal is to display all these values using a box plot, something like this. Okay, so we need to build our box plot. Okay, so we need to first to consider the position of where is the Q2. Q2, remember, is always the median. We need a number line. So here I have this is my number line. So I'm going to add the median. This is Q2. Okay, this is Q2. So for me, it's easier if I add this, and this is my Q2, the median. Okay, so here comes the trick. We need to determine the change or the size of our number line. We can increase maybe every 3 units, 5 units, because according to this is going to be the size of the box plot. So for example, also is something super important to check the minimum value and the maximum value, because as you can see here, this is the minimum, the maximum. So if the minimum value, if this is 10 and this is the maximum 41, so maybe a good number line would be, I don't know, maybe increasing by 3 units. So we can do something like this. Let me modify my number line. This is my number line. Okay, so I have the minimum, that is 10 here. This is the minimum, this is my maximum. Okay, and also we need now to add Q1, Q2, Q3. Well, this is Q2. So we are going to add the Q1. Q1 is located at 21. So we need to check. So this is obviously an estimation. So my Q1 maybe is here. This is my Q1. Okay, so this is Q1. Where is my Q2? No, sorry, Q3, 31. So 31 is maybe here. Q3. What else? We need to build the box. So we are going to close this and this. Now we have the box. What is missing? The whiskers. The whiskers is this, the section, the minimum and the maximum. So from the Q1 to the minimum that we already know that this is 10. So from the Q1 to 10, this is the minimum. Okay, this is 10. Then from the Q3 to the maximum, remember the maximum is 41. So this is to the maximum from 41. This is the maximum. That's it. This is the box plot. Remember, an outlier is a number that is super different. It could be because it's super huge or super small, but it's different than the others. Okay, so we need to remember these formulas. In order to find outliers, we can use these two formulas. Less than the lower quartile minus 1.5 times IQR. Remember, lower quartile is Q1. Okay, the lower quartile, this is Q1. The upper one is going to be Q3. Okay, this is a reminder. So by using these two formulas, we are going to find the numbers that are outliers because they are less than, because remember, the distribution of the data set is concentrated here. So if we use less than, we are going to check if we have numbers super different because they are smaller. When we are going to use greater than, is because we are going to find all the numbers that are outliers because they are different, because they are greater than, they are huge in comparison of these values. Okay, so what do we need to do? Okay, using first, we have this using less than. Okay, less than. We need, this is the IQR. Okay, first we need the IQR. What is the IQR? If you remember, there is a formula here, IQR. Let me do this bigger. We have the IQR is Q3 minus Q1, upper minus lower. According to this, in our example, Q3 is 31 minus what? Q1, 21. So this is 10. Okay, so our IQR is going to be 10. Okay, so when we have using less than, we have this LQ is Q1, Q1, as you can see here, Q1 is 21. So following the formula is something like this. Q1, the lower quartile, 21 minus 1.5 times 10. Okay? This is using our values. So basically, this is like 21 minus 15. And what is this? So what is the meaning of this value? Okay, what is the meaning of this? All the values, we can say all the values is smaller than 6, they are outliers. Okay, all the values is smaller than 6, they are outliers. That is the meaning of this when we are using less than. So you can see here in the original data set, here if we have numbers smaller than 6, we will have outliers. This is not our case because the minimum is 10. So we don't have outliers because they are super small or smaller than. Then we need to do the same, but now using greater than. Greater than. So remember, this is the formula. So now using greater than. Again, upper quartile is going to be the Q3. So we can check what is Q3 in our example. Q3 is 31. So we have, following the formula, 31 plus, this is something different, 1.5 times 10. Remember, IQR is 10. So here we have 31 plus 15. Okay, plus 15. So this is easy 46. What is the meaning? So all the numbers greater than this, greater than 46, they are outliers. Okay, so all the numbers greater than 46, they are outliers. So we can check according to this. Nope, we don't have outliers because the maximum value is 41. We can check the box plot. The maximum value is going to be 41. So in this case, number 2, determine the outliers. We can say, nope, we don't have no outliers. We don't have outliers. That's it. That is number 2. Then guys, finally for the number 3, based on the box plot, describe the skewness. The skewness means the shape of the distribution. We need to check to consider these shapes. Okay, we only have 3 options. The first one, negative skew or left skew. The second one, symmetric, we can say no skew, or also we can say normal distribution. And the last one, right skew or positive skew. So how can we identify our box plot? We need to check 2 things. The first one is the size of the boxes. As you can see, we have inside, well, this is the box, but we have 2 boxes. This is the box number 1 and this is box number 2. So we can check the size. That will be the first thing that we need to consider. And then the difference of the whiskers, the length, which is bigger. Okay, so first, let's check our box plot. The difference of these 2 boxes, okay, we have 5 and 5. So maybe you can think, okay, it looks like this is a symmetric or normal distribution. But also we need to check the size of the whiskers, this one. So this whisker is bigger than this one. How can we know? Because the difference between 21 and 10 is 11. And then the difference between 31 and 41 is 10. So just by a little bit, slightly bigger is this whisker, the minimum. Okay, so from Q1 to the minimum, this is just a little bit bigger. So we need to check the shapes. When we have the situation, when this is bigger, when this is bigger than this one, obviously, is because we are talking about a negative skew just by a little. Okay, so that unit is the difference between the symmetric and the negative skew. So we can say is a negative skew. And that's it.